Good morning, students. Today we shall continue with your same chapter, that is atomic structure. Come to the topic ionization enthalpy. It is also known as ionization energy. Students, when we provide some energy to the atom, then the electron present in that atom goes to the higher energy level. But when a sufficient amount of energy is provided, then that electron, which is loosely bounded, gets lost from the atom and converted into gaseous cation. So the ionization enthalpy or ionization energy, it is the minimum amount of energy that is used to overcome the force of attraction between the most loosely bound electron from the protons, that is known as ionization energy. So we can write it as the minimum energy provided to remove the electron from isolated gaseous atom. So that is the ionization energy. Students, you know that electrons, they are held together by the proton through strong electrostatic force of attraction. In order to overcome that force of attraction, the energy has to be provided. And when that sufficient amount of energy is provided, then the most loosely bound electron, that is valence electron, gets removed and it gets converted into gaseous cation. Now students, here we remove the electron from gaseous state because you know that in the gaseous state the atoms are they are apart from each other, they are widely separated, so the interatomic forces of attraction are minimum. So that is about the ionization energy. The unit of ionization energy is kilojoule per mole. This is the unit of ionization energy. Okay students, next come to the successive ionization energy. Now you are clear with the term what is ionization energy. Successive means it is the amount of energy which is required to remove the subsequent electrons, that is first, second, third, etc. electron from the isolated gaseous atom. Suppose we consider an example, aluminium. It has 3 valence electrons. Now in order to remove the electron, we have to undergo in a stepwise manner. In order to remove first electron from the neutral aluminium atom, the ionization energy IE1 is to be given. Now aluminium, it has the configuration 1s2, 2s2, 2p6, 3s2, 3p1. Now when one electron is to be removed, the configuration becomes 1s2, 2s2, 2p6, 3s2. The p subshell will be completely removed. Now since one electron is being removed here, but the protons remains same, so the hold of the proton on the remaining electron will increase, due to which the force of attraction will increase. Now if you have to remove the electron further from this aluminium positive, more ionization energy is required. So after giving IE2 to the Al1 positive ion, the configuration will be 1s2, 2s2, 2p6, 3s1, that is it will be Al2 positive. Now here the hold of the proton on the electron will further increase because here also the removal of one electron takes place. Now after removing the another electron, third electron, we have to give more ionization energy, that is IE3, because this Al2 positive, in order to remove the electron, the size is very small, effective nuclear charge per electron is more, so the ionization energy IE3 will be more. So the trend of the ionization energy is IE1, it is less than IE2 and is less than IE3. So the successive ionization energies always increases. Now come to the factors which affect ionization energy. The first factor is nuclear charge. Students, as the nuclear charge increases, the electrons which is present in the outermost shell, they will feel more attraction towards the nucleus. So in order to pull out the valence electron, more ionization energy is required. So we can say that ionization energy is directly proportional to nuclear charge. So with increase in nuclear charge, the ionization energy increases. This is the one factor. Now come to the second factor, atomic size. As the atomic size increases, the force of attraction felt by the valence electron will decreases. So only a lesser amount of energy will be able to remove the valence electron. So it means ionization energy is inversely related to the atomic size. With increase in atomic size, lesser amount of ionization energy is required to pull out the valence electron. That is the second factor. Now come to the third factor, that is the penetration effect. Now the ionization energy, it increases with the increase in the penetration effect of electrons. Students, the probability of finding the s electrons towards the nucleus is much more than that of p and then d and then f. So the electrons present in the s subshell, they feel more attraction towards the nucleus. So in order to knock out or to remove the electron from the s subshell comparative to p subshell, more ionization energy is required. So in a nutshell, we can say that the penetration effect of the subshells is in the order S has greater penetration effect than P, greater than D, greater than F. So the ionization energy decreases in the same order, means more amount of ionization energy is required to remove the S electrons rather than E, then D and F. So this is the penetration effects on the ion factor which affect the ionization energy is the shielding effect or screening effect of the inner shell of electrons. With increase in the screening effect of the inner shells, the ionization energy decreases. Actually what happens in multi-electron atoms, the electron feels two types of forces, attractive force from the nucleus and repulsive force from the electrons which are present in the inner shell. The overall effect of the two opposing forces is that the net attractive force on the electron gets decreased. The actual charge felt by the valence electron is known as effective nuclear charge, and the repulsive forces felt by the outermost electrons from the inner electron is known as screening effect. So we have Z effective equal to total nuclear charge minus screening effect or shielding effect. So with increase in the shielding effect or with increase in the repulsive forces due to the inner shells provided to the outermost electrons, the effective nuclear charge will decrease, due to which ionization energy also decreases. So the ionization energy is inversely related to the shielding effect. The last factor which affects the ionization energy is the electronic configuration. Students, as you are aware that half-filled or completely filled configurations, they are more stable because of symmetrical distribution of electron. So the ionization energy required to remove their valence electron is very high. For example, if we consider the two atoms, nitrogen and oxygen, the atomic number of nitrogen is 7. Its electronic configuration is 1s2, 2s2, 2p3, and in place of oxygen, whose atomic number is 8, the configuration is 1s2, 2s2, 2p4. Now, the maximum number of electrons that can be accommodated in p orbital is 6. Now, in nitrogen case, the P has exactly half-filled configuration, and this configuration is more stable rather than oxygen. So more ionization energy is required if we have to remove the electron from P subshell. So the ionization energy of nitrogen is more than that of ionization energy of oxygen. Similarly, if we consider the noble gases which belongs to group 18, they have the highest ionization energy because they have completely filled stable configuration. So if we have to remove the electron, very high ionization energy has to be provided, which is not possible. So the noble gases have highest ionization energy. Now next come to the variation of ionization energy, that is how the ionization energy varies across the period and down the group. Students, as we move across the period, the new electron is being added in the same shell, due to which effective nuclear charge increases and hence the size decreases. So across the period we know that the size decreases. Now when the size will decrease, the outermost electron will feel more attraction towards the nucleus. So in order to knock out these valence electrons, more ionization energy is required. So with decrease in size, ionization energy increases. So across the period, the ionization energy increases because the size decreases. Now come to down the group. As we move down the group, the number of shells goes on increasing and ENC per electron decreases, due to which the atomic size it increases. Now we know that as atomic size increases, the outermost electron will be felt less attraction towards the nucleus, hence only small amount of energy is sufficient to knock out that electron. So with increase in the atomic size, ionization energy decreases. So down the group, ionization decreases with increase in atomic size. Okay students, now come to the next topic, that is electron gain enthalpy. Now in ionization energy, it is the energy which is required to remove the electron. But if we have to the electron enter inside the atom, then the energy will be released because the added electron will feel attraction towards the nucleus. This energy released when one electron is added to the isolated gaseous atom is known as electron gain enthalpy. So it is defined as the amount of energy released when one electron is added to an isolated gaseous atom. Now why I have written one electron? Because if we add one electron to the oxygen, it will gain that electron and gets converted into anion O negative, and the energy will be released in this case. So the enthalpy gain will be negative here. But if we add another electron to the anion, then it will feel repulsion because this oxide ion is already rich of electron, and when we further add electron to it, the electronic repulsions will dominate over the attraction. So in order to overcome the repulsion, we have to give the energy. So in this case, the electron gain enthalpy will be positive. That is, energy will be absorbed here. So that is the electron gain enthalpy. It is the energy released only when one electron is added to the isolated gaseous atom, and successive electron gain enthalpies are always positive because in order to overcome the force of repulsion, we have to provide the energy. The unit of electron gain enthalpy is the energy, so it is also measured in kilojoules per mole. Now next, come to the factors which affect electron gain enthalpy. The first factor is nuclear charge. As the nuclear charge increases, the force of the attraction on the incoming electron will also increase. So the incoming electron will be easily accepted by the atom. So it means with increase in the nuclear charge, the electron gain enthalpy will be more negative. That is, more energy will be released when the incoming electron will accept more attraction towards the nucleus. The second factor which affects the electron gain enthalpy is atomic size. With increase in the atomic size, the attraction between the incoming electron and the nucleus will decrease. So the incoming electron will not be accepted with that ease as in case of smaller atom. So when the atomic size increases, the electron gain enthalpy will be less negative. So with increase in atomic size, the electron gain enthalpy will become less negative because it feels lesser attraction towards the nucleus and will not be accepted with that ease. Now come to the third factor, which is electronic configuration. Exactly filled or half filled configurations are more stable because of the superior distribution of electrons in them. So if we have to add the electron to them, they will feel repulsive forces. So in order to overcome that repulsive forces, the energy is being absorbed. So in this case, the electron gain enthalpy will be positive. So exactly half filled and completely filled configurations are more stable, so their electron gain enthalpy will be positive in order to overcome the repulsive force if we have to enter the electron in them. Now next, come to the variation of electron gain enthalpy across the period and down the group. As we move across the period, atomic size decreases and the nuclear charge increases. Both these factors increase the force of attraction for the incoming electron towards the nucleus. Thus, as we move across the period, electron gain enthalpy becomes more and more negative. It becomes more and more negative. This is a variation across the period. Now come to down the group. As we move down the group, the nuclear charge, the atomic size, nuclear charge no doubt increases, but the atomic size also increases. Now the incoming electron will feel lesser attraction towards the nucleus and thus electron gain enthalpy become less and less negative. So down the group, electron gain enthalpy will become less and less negative. Now students, come to the next topic, some trends in electron gain enthalpy. Halogens, which belong to group 17 members, they are known as halogens. They have the highest negative electron gain enthalpy. Now what is the reason behind it? The general electronic configuration of halogen is Ns2Np5. Now they exactly have one electron less than noble stable gas configuration. So they have a strong attraction for the incoming electron to have noble gas configuration, that is Ns2Np6. So the electron gain enthalpy of halogen is highly negative. It is highly negative. Now students, we also know that as we move in the halogens down the group, the electron gain enthalpy, it decreases because down the group the atomic size increases. But there is the electron gain enthalpy of chlorine is slightly more than that of fluorine. Now the actual order is chlorine is more electronegative than fluorine, then bromine and then iodine. Now what is the reason behind it? The reason is that the fluorine atom being very small in size, the electron density in the fluorine is very high. So the incoming electron will feel more repulsion rather than attraction. So the incoming electron will not be accepted in case of fluorine with that ease as in case of chlorine, which is sufficient bigger in size, and the incoming electron can be accepted easily here. So the electron gain enthalpy of chlorine is more negative than that of fluorine. So this is the first trend about the halogens. Next come to the noble gases. Noble gases, they have completely filled configuration, that is NS2 and P6. So they have stable configuration. So for that, if we have to add additional electron to it, then in order to overcome the repulsive forces, we have to give the energy. So the noble gases have highly positive electron gain enthalpy. Highly positive electron gain enthalpy. Okay student, next come to the electronegativity. Now before coming to the definition of electronegativity, consider an example of hydrogen. This hydrogen molecule consists of two hydrogen atoms. Each hydrogen atom will share one electron. Now the shared pair of electrons, they will lie exactly midway of the two hydrogen atoms. Now if we consider the case of hydrogen chloride, HCl, the shared pair of electrons, they will not lie midway but they lie more towards the chlorine, as we know that halogens are most electronegative. So the shared pair of electrons, they will lie more towards the chlorine atom, due to which this chlorine atom will acquire partial negative charge and the hydrogen atom will acquire partial positive charge. So this tendency of an atom to attract the shared pair of electron towards itself is known as electronegativity. So we can define electronegativity as the tendency of an atom to attract the shared pair of electrons, towards itself is known as electronegativity. Now students, we know that as we move across the period, the atomic size decreases. So the tendency of an atom to attract the shared pair of electron increases. Hence across the period, the electronegativity increases. And down the group, as the atomic size down the group increases, therefore the electronegativity, it decreases. That is, its tendency to attract the shared pair of electrons decreases. So this is the trend of electronegativity across the period and down the group. Now this electronegativity differs from electron gain enthalpy. This electronegativity, it is just the tendency of an atom to attract the shared pair of electron. But electron gain enthalpy, it is the energy released when one electron is added to the isolated gaseous atom. So another difference between electronegativity and electron gain enthalpy is this electron gain enthalpy, it has the unit kilojoule per mole, but electronegativity, it has no unit. And third, you can differentiate it. Electron gain enthalpy, it is the property, it is the energy released of isolated gaseous atom. But this electronegativity, it is the tendency of bonded atom to attract the shared pair of electron towards itself.